In this video, we're going to take a look at implicit differentiation. Let's start with an equation that involves both x and y. For example, 7x squared y plus y squared plus x all cubed is equal to x to the fifth. In this case, we would say that y is an implicit function of x. Intuitively, what that means is that x and y are tangled up in this equation, so it could be difficult or even impossible to get a formula for y. Now, as a little warm-up, let's take a look at a few quick derivatives here. Derivative with respect to x of x cubed, well, that's equal to 3x squared by our usual power rule. But if we take the derivative with respect to x of y cubed, it's going to look a little bit different because in this setting here, y is an implicit function of x. So when we take the derivative with respect to x of y cubed, we are really using the chain rule. We're going to take the derivative of the outside function, so derivative of y cubed with respect to y looks like 3y squared, but to get this derivative in terms of x, we'd have to multiply by dy by dx. So perhaps a better way to understand this is just to introduce a new variable here. Let's say w represents y cubed, and we can think of what dw by dx should equal. dw by dx should equal dw by dy, which we should be able to calculate, and then multiplied by dy by dx. So that is just the chain rule used with the variables w, y, and x. So in other words, if we rephrase this in terms of the previous line here, derivative of y cubed with respect to x should be dw dy, which is 3y squared, times dy by dx. So notice the pattern here. When we take a derivative with respect to x, things work as usual, as they did earlier on in the course. But when we take a derivative of a function involving y, we're going to have to multiply on this factor of dy by dx. So let's try a few other quick examples just to make sure that we've got this idea down. Okay, anytime y is an implicit function of x, if we try to take the derivative with respect to x of something like y squared plus x, we'll take the derivative of the first term. That will be 2y times dy by dx. We have to multiply on a factor of dy by dx because we've taken a derivative of a function involving y. And then we'll add on the derivative of x, which is just 1. Okay, one more warm-up example. Derivative with respect to x of xy. Well, we'll have to use the product rule here because we've got two factors in this expression here that we're trying to take the derivative of. So our product rule says write down the first factor, multiplied by the derivative of the second factor, which would be dy by dx. And then we're going to go plus the second factor times the derivative of the first factor. So derivative of x is just 1. In other words, our derivative is x times dy by dx plus y. All right, so with those ideas in mind, whenever we're dealing with an implicit function here, y is an implicit function of x, and that means we have to be a little bit careful when taking derivatives of terms that involve y. So let's try a more standard problem now for this section. So we'll go back to the first equation that we had written down here, 7x squared y plus y squared plus x all cubed is equal to x to the fifth. So right away we can tell that y is an implicit function of x because this equation has the x's and y's all tangled up. The problem is going to be to find dy by dx. So I'm going to break this type of problem up into steps. Step 1, we're going to take the derivative with respect to x, so take d by dx of both sides of the equation. All right, so let's take a look back at our equation here. The first term that we run into is actually a product, 7x squared y. You may find it a little bit helpful to decide in advance how we want to break that up into factors. So you may just want to write down somewhere here. Let's think of it as 7x squared times y. And the reason I choose to break it up that way is it's easy for us to take the derivative of 7x squared. It's easy for us to take the derivative of y. So this will help us manage the product rule a little bit easier. All right, so let's start with our derivative. According to the product rule, the derivative should be first factor times the derivative of the second factor, so times dy by dx, plus the second factor times the derivative of the first factor. Okay, so these two terms here, these come from using the product rule. Okay, now we're going to move on across our equation. We're now going to take the derivative of this cubed term, and there's now going to be a chain rule involved here. So we're going to take the derivative of the outside function, the cube. We'd have 3 times the inside function squared. The inside function stays the same. So we'd have y squared plus x in there. And then this has to get multiplied by the derivative of the inside function. So derivative of y squared is 2y times dy by dx. I didn't quite leave myself enough room there. And then derivative of x is going to be 1, so we'll go plus 1, just close our brackets there. So this entire expression comes from the chain rule. Okay, and then as we keep reading across our equation, derivative of x to the fifth is 5x to the fourth. So that is our first step completed. We've got all our derivatives done here. Step 2. What we're going to need to do is get the dy by dx terms on one side of the equation. Often we'll try to get them over on the left side, but really it doesn't matter. Just get the dy by dx terms over on one side of the equation. The non-dy by dx terms should go over on another side on the other side of the equation. Now, this may take a couple of steps depending how much expansion we have to do here. So let's start with just getting this cleaned up. Okay, we've got 7x squared times dy by dx plus, we might as well write this second term as 14xy. Okay, and then we get into this chain rule expression here, and this is where we're going to need to think a little bit. We want to get dy by dx terms separated from non-dy by dx terms. So what I would do is think of all this stuff here, just think of that as one thing, and we need to take that one thing and distribute it across this bracket here. So we need to do actually 2 multiplications. Okay, one of these terms will end up being a dy by dx term. The other term will end up being a non-dy by dx term, and we need to get those 2 terms separated. Okay, there's no need to fiddle around with what's inside this box. There's no need to expand this square because these are all non-dy by dx terms. Okay, so let's do this multiplication. Let's think about just multiplying the 3 times the 2y. We'd have 6y times that square times dy by dx. Okay, and our second term coming from this expression here is going to look like 3 times the square. Okay, so that's that all expanded out. No further expansion required there, and that is still all equal to 5x to the 4th. Okay, so we really need one more step here to get all the dy by dx terms on one side. So let's keep dy by dx terms on the left. Okay, I'll just cross them out as I use them. I got this one and that one. And our other terms, our non-dy by dx terms, need to get moved over to the right. So the 5x to the 4th is already over there. These two other terms are going to have to move over and change their signs. So we'll have a minus 14xy and a minus 3 times that square there. So you can just double check that you've used all your terms and that you've got the correct signs, particularly on any terms that have been moved over to the other side. So that all looks great. Okay, next step. Step 3, we're going to factor out the dy by dx. So on the left side, we had 2 dy by dx terms. So let's pull the dy by dx out there, and we can write down what we had. We had a 7x squared, and we had a plus 6y times y squared plus x all squared. Okay, so those were our 2 terms on the left. And over on the right side, we had a 5x to the 4th minus 14xy. We had a minus 3 times that square term. Okay, so factoring out the dy by dx, generally fairly easy because we've already got our dy by dx terms over on one side. And then finally, very last step of the problem, we're just going to solve now for dy by dx. So all that's involved here is we're going to divide through by whatever is in this bracket here, and that will leave just a single dy by dx over on the left side. So dy by dx is equal to our whole right side divided by everything in this bracket here. And that is our final answer to the problem.